what's up? Welcome back to another very exciting tutorial. Today we will take a look into the VFX world. We are going to learn how to integrate fire and smoke into some drone footage of one of the most popular sites in Vienna. I recently took my drone, captured some cool scenes and had the idea to add fire and smoke to one of the pods on the Vienna's Giant Ferris Wheel. This will be fairly a long tutorial because we will using different software packages to complete this task. We will use After Effects for compositing, Cinema 4D for integrating 3D objects, Plasticity for modeling the 3D object, SynthEyes for 3D camera tracking, and Embergen for the fire and smoke simulation. A cool software package. I will show you the complete workflow on one scene, and all other scenes were created in the same way. So, without further ado, let's get started. Okay, first of all we are in DaVinci Resolve and export our backplates. In this case I choose a PNG sequence because PNG sequences can be handled in any other programs very well, After Effects, SynthEyes, Cinema 4D. I choose a folder and a file name and leave everything on default settings except the compression level. I choose 0 compression because you don't have any artifacts in it. Choose the right in and out points and render it out. Okay, now we are in SynthEyes and I choose new project. I choose our backplate, which we have exported right now, and select 25 frames per second and click OK. Okay, now we are in the main view, let's say, and we can scroll through the whole footage, and we usually can make an automatic 3D camera tracking, but I tend to make the advanced features. I go into the features room, change some settings, in this case the small blip size to 3 and the big blip size to 6, and increase the maximum tracker count to 400. After that I choose blip all frames, and you see a lot of blue and red dots, and these will become our trackers. The trackers are in green color, and you see here are the trackers on the footage, and let's give it a try. So the first impression looks very promising. And I personally tend to add an additional tracker, an own tracker, and therefore I create a tracker on the housing itself where our smoke and fire explosion should be integrated. So I make some adjustments on the tracker itself. I choose the tracking area to decrease it a little bit, and make some adjustments again, so you can see on the left side on the zoom window how it is positioned the tracker. So I guess it's okay, and then I hit the space button and let's automatically track my point. Perfect. So we can check the whole tracker again. Wow, it's locked in place perfectly. I think it will be a very good 3D solver. So we are going into the solver room, and we have all trackers what we need, and we can then calculate our 3D camera track. Therefore we are going into the solver room, I said, and hit the go button. And in just real time we have a 3D camera solve with an error level of 0.57. This is a very good result because everything below 1 is a very good camera track. And when we are changing our layout to the quad perspective and lock the camera, then we can see that all trackers are perfectly aligned, and so we have a very good camera solve. I love this. Okay, so we can even decrease the error level from 0.5 to a lower size when we integrate the lens workflow because when we see our footage, our backplates on the buildings behind, there are no straight lines. That means the camera has some distortion, and we can integrate it with the lens workflow to decrease the error level again. But in our example, I don't want to integrate the lens workflow because it's tracked from my point of view with a level of 0.57. It's okay. But anyway, we will optimize our 3D camera tracker. So we go into the menu of clean all tracks, clean up the trackers, and we have the possibility to select the trackers with a high error number. So we can see we have 18 trackers with a high error number, or 5 trackers with a very short lifetime. And so we can select them and hit the button fix, and these trackers are removed from our scene, and we can refine the whole 3D camera solve. And wow, we have a tracker error code from 0.3. Perfect. Wow, every tracker is now perfectly aligned and locked into the 3D camera solve. So we have many tracking data, and in the 3D room, I don't want to export all tracking data into After Effects because it's slowing down unnecessary. We don't need any tracking points, just the camera and some tracking points, the origin. And I go to the file menu, and then I will export it to After Effects with a JavaScript. I choose the folder and the name, click Save. And the next dialog, I leave everything on its default values and hit the OK button. And it launches automatically Adobe After Effects. And right now we're in After Effects, and all exported camera trackers are here. The backplate is here, and everything is perfect. So the next step is to export the project to Cinema 4D. And we get a warning that 2D layers, in our case it's the footage, cannot be exported. That's no problem. We choose the right folder and the name and click on Save, and we are launching Cinema 4D. To make it easier to follow along, you can download the complete project files for only $5. Included are the drone footage, the 3D tracked camera data, the CAD file from Plasticity, as well as from Cinema 4D, the After Effects rotoscoping stuff, and the fire and smoke simulation in Embergen. A lot of data to play with. You will find the download link in the description below. In Cinema 4D, we open the project we just exported, and we see that we have a null object, and in the null object we have the tracking data and the camera. But where is our footage? Because After Effects doesn't export footages or 2D layers, just 3D objects. So we have to go into the settings and change the render settings from standard to redshift, because we are using redshift. And we have to convert the camera from the standard camera to a redshift camera, and there we have the background tab where we can include our footage. In the image, we are choosing the backplate, and it doesn't animate. That's no problem, because we are going into the image and to the animate tab. Change the mode from off to simple, and change the frame rate to 25, our frame rate, detect all frame rates, and we are good to go to animate our backplate. Perfect. So the next step is to test if we integrate a 3D object like a cone and include the cone to the original point. So we just change the radius and the height, so it matches the perspective, and include the cone into the origin tracking point, and zero out all position data, X, Y, and Z, and also the rotation data to 0. and then we will rotate the whole cone in 180 degrees to 180 degrees, that the cone itself is standing on its top. And yeah, perfect. So we will align the axis also. Therefore, we are going into the axis center menu and change the axis, enable the auto update and the viewport update, and change the Y position to 100%, so it's on the top. And we now have to zero out the value again, and now the cone is standing on top. Now we can test it, and it's absolutely perfectly aligned to our original point or tracking point, and so we can integrate any 3D object camera tracked perfect. So the next step is to save the project and do a little bit of housekeeping. So delete all other trackers we don't need anymore. And now it's time to build up the 3D model for our housing. That means that we need possibility to have a 3D object with windows in there, which have the same size as the cabin here on this backplate, so we can integrate the fire simulation. So I developed my 3D objects in Plasticity. It's a CAD program designed for creative persons, and changed the top view, took my rectangle tool, and there I eyeball more or less the size, the shape of the cabin, of the housing, took the extrude tool, extruded up, and we are now changing the shape more or less to the size of the cabin in the backplate. So the next thing we have to model is the rooftop. When we see our backplate, a picture of it, then we see that the rooftop is a rounded rooftop. So we have to model this in our CAD program also, and this is no problem because we are changing the tool to a 3-point arc tool, and here we go. And we click on the center, and we have the rooftop perfectly aligned. We then extrude the edge from the rooftop and move it along the axis. So now we can move the whole face to the box itself with a free move, so that the edge is cutting the box itself, and then we can do a Boolean operation. So perfect. And now we can do the Boolean operation where we choose the rooftop and the box itself, and now we can delete the two faces, and now we have the whole solid housing in the shape. The next thing what we have to do is to make it a room. So we have to hollow the whole shape. There is a operation for that, hollow solid. And when we click this, we can then, so we click this, we can then choose how thick the walls should be. And there we have an inner room. And when we are doing the windows, we can then see that the whole housing itself has walls. That's perfect. Now we are concentrating on our windows, and therefore we are going into the picture, and we see we have 4 windows. We're just eyeballing them, so we are it's on the top edge from the rooftop, and we are going into the rectangle tool and draw 1 window. Just eyeball it, and looks promising. And then we are going into a special menu in Plasticity. It's called the rectangle area. There we can say we will have 4 windows, and stretch it out to the other side. Right click. Yeah, looks promising, perfect. Right click, and now we have the 4 windows. We select the solid itself, and we are doing an extrusion of it. Extrude it right away. Move the 4 windows and do a Boolean operation again. So we will select the first solid and the 4 windows, and now we can see we have perfect room with walls and the windows. Now let's concentrate on the other side. We are selecting the face and do also the windows. Now we see we have here 6 windows. Okay, perfect. So let's try and eyeball it to make a rectangle. Okay, it's a little bit high, I guess. Should be on this side. Okay. And go into the rectangle array again. And we are changing it from 4 to 6 because we have 6 windows. And we see that they are overlapping each other. That means that our window is a little bit too big. So we change the size. We scale it on the y-axis. Do a little bit of movement and try the rectangle array again. Okay, let's see, we have 4. Let's change it to 6 windows, and it's working perfect. Okay, the steps are also the same as before. We are selecting the face and do an extrusion of the 6 windows. So extrude it, move it on the z-axis and do a Boolean operation. Select the solid and select the 6 windows and do a Boolean operation. Perfect. Now we have more or less the shape of the housing. And we can now select the edges and can maybe do a little bit of filling so that looks nicer, but it's not really necessary in our case because it's just the template for the fire and smoke. It's just the collider object itself. So the next step is to export the object itself, the 3D object, and because we are integrating the object in Cinema 4D, we are exporting it as an OBJ file, And in the OBJ file, we have the possibility to export it as triangles, quads, or n-gons. I choose quads, so we can show the quads itself. And I choose a density of 0.8. And everything is on default. I click the OK button, and we are now in Cinema 4D again. Now we are opening in Cinema 4D the OBJ. We just exported it from Plasticity. So we are doing a merge of the OBJ, and we are integrating it in Cinema 4D. Now let's just do a quick overview. Perfect. The house is perfect aligned with the camera data, with the 3D camera track. And now we are ready to save the file and doing the smoke and fire simulation. So you can see it's perfectly aligned. If you like this tutorial, then please give me a thumbs up, leave a comment, and subscribe to my channel. I would be very happy to stay in contact with you. Let's save it and export it as an FBX. In the FBX settings, I think I just leave all settings as it is on default settings. So we are exporting the camera, we are exporting all colors, tracking data. I think it's just the default settings on the FBX. Give it a name, choose a folder, and click on save, and we are opening Embergen. So in Embergen, we are doing the whole fire and smoke simulation. Here comes the fun part. First of all, we have to import our FBX. We just exported it from Cinema 4D with all the camera data, with the housing of the 3D data. So we just do an import. So we choose the file path of the FBX, and right away we can't see the FBX because the domain of the simulation is not the right size. So we go into the node of the import and scale and center it to fit. Now we can see the import is working. Okay, so we go into the render settings and don't render all, just the right thing we need. So we need just the gondola, we need just the house itself as the collider object, which we'll do later on. So first of all, let's disable the emitter and do a new one. We do a volume emitter, and as a shape we choose a primitive shape. In our case, I think it's the best way to go with a box emitter. So we have to resize the box emitter so that it is sitting inside the housing itself, so that the housing itself will be the collider. So first of all, let's resize, and let's resize the emitter, go up with the position, change the position, and afterwards the rotation. Okay, I think it's okay. Let's resize it on the y-axis, resize it on the x-axis, a little bit smaller, and do the right position. See the axis also, and do the rotation. Okay, and now the emitter is more or less perfectly aligned inside the house. And now we have to tell the system that the house itself is the colliding object, so that the flames and the smoke is don't go through the rooftop. So therefore we are going into the imported object, and let's see, we are going into the simulation and add a new collider object. And in the collider object, we say that the mask 1 of the import object is the collider itself. Perfect. And now the flames and the smoke are working. And from now on, we can build up the simulation. So let's put in some additional pressure. And we see that the smoke and fire are coming out of the windows. Perfect. I like this. We see more or less immediately that we have a problem where we have to fix the domain itself, the simulation domain, the borders itself, but we will fix that later. First of all, we are importing the camera so that we can see the right backplate of it to make the light and the shading. So the camera itself is in the unnamed import slot, and we are integrating the camera also in the render settings. The camera, the default camera, we delete this default camera and the redshift camera into the camera slot of the render settings. And now we have to go into the import node and change the frame rate from our footage and from our camera to the frame rate of the simulation of Embergen. I know this is a little bit of let's say difficult task. It's difficult to understand because the frame rate of the simulation in Embergen is on default 60 Hertz, and when your backplate is on 25 frames or 30 frames, it doesn't match the simulation speed. So therefore you have to change the simulation speed, the frame rate, and the render settings on three different nodes: the render itself, the camera settings in the camera node, and the import node. There is a very good explanation and a very good tutorial from Embergen which explains this in a very detailed manner. There is also a formula behind that import node where you can check your frame rate and which settings you have to choose to match the simulation speed of Embergen. So in our case, we are changing these numbers. As I said, I will link the tutorial in the description below. And we are back and change the size of our camera settings. It's a full HD, so we have to change the render settings, and you have to change the camera display resolution so they can match on a full frame basis. And right now, when we change our redshift camera and we are resetting the simulation, we can now see our animated backplate with the simulation again. I personally think that there is a bug in Embergen, because when you switch off just the backplate, the animated backplate, the simulation is again in real time. And when you enable the backplate, the animated backplate, again, it's slowing down the animation. However, we can see the problem here of our domain, of our simulation domain. It's too small. So we go into the simulation and increase the voxel count, the domain size of the voxel count. It will slow down the simulation a little bit because we have the GPU has to calculate more than 4 times more voxels than before, but the speed is unbelievable quick, I guess, and the simulation now is working perfect. The domain of the simulation is on the perfect size, and now we let's prove the simulation again. Okay, I like this more or less, but we can now work on the whole simulation with more fire, more smoke, and do the right lighting and include some forces, wind forces, some noises to make it even much more dramatically, I say. So yeah, we will change the different settings, and we will back in just about 5 minutes, and then we can see the result. Okay, we are back with the simulation, and we changed some settings within the smoke and the fire settings, also the forces and the noise type a little bit, and you can see some mini explosions in the smoke. Wow, I like this. It looks very promising. So it's time to export the whole simulation. Choose a folder, choose the right name, and export it as a PNG sequence. It often happens so quickly that it's not worth it getting a coffee in the kitchen. Imagine you have to render that in your 3D program. That would often take hours, not minutes. Personally, I think this is a revolution in fire and smoke simulation. And now JangaFX is bringing it to liquids. It's called LiquidGen. Unbelievable. Okay, we are ready. We are finished in rendering, and now we are back in After Effects. Now we can import the PNG sequence of the simulation, and we are putting it on top in our composition, and now we can see the simulation. It's working with the backdrop perfect, the backplate perfect. It looks very good. Look at this small explosion here. Wow, I love this. It's so cool. But it doesn't look, it looks good, but it doesn't look good either. And the reason for that is that we have to mask out the roof. We have to mask out the front and the side panel, which is not on fire. So we have to duplicate the footage and open the effect panels and choose the Mocha AI for masking the right things out. Okay, now we're in the masking tool, and we have to zoom in, and we are concentrating on the front panel, on this panel and the side panel and the roof. These are the three main things we have to mask out where the explosion and the fire is coming not through the walls and not through the ceiling. So I take the mask tool and draw a rectangular on the forefront and adjust the rectangular that it matches these 4 points as much as precise as possible. So there are so many tweaks from the camera settings, 3D camera tracking, masking, simulation. But to be honest, it's very important to be precise and to give this a little extra detail and spend much time as possible. In the end, it's important, and you see the difference. And this tracking point, you have the possibility to color it so that you can see it much better. You can also increase and decrease the opacity of this rectangle, of this color. And we are switch on the perspective, and now just fine-tuning, and let's track the whole thing forward. And now we can see that it's a pretty good job. Mocha is doing a pretty good job. A little bit of tweaking on the last position. And when we tweak the last position, it automatically includes an additional marker, and the markers between are also calculated so that it matches again the perspective and the whole tracking data of the mask. So it's very convenient. For our example, it's working perfectly. I think it's perfect. We are locking this mask and we are concentrating on the second one. So we are creating again a rectangle as we did before and tweaking the points of the rectangle. Okay. And now we can track the perspective of the side panel of this house, doing some adjustments on the points and on the key points from Mocha AE. And now we are finished. We are locking in the second layer, save it, and close Mocha AE and return to After Effects. In After Effects, we have the possibility to validate the two layers, and we can convert them into After Effects masking layers. And now we have two masking layers in After Effects. We can control them, and we see that the edges are perfectly, but they are a little bit too, let's see, sharp. Fire is not coming out as such a sharp edge from such a smart edge. So we have to feather them out a little bit, and we are going into the mask and into the feather, and we are feathering them out. Perfect. And also on the second layer. And now we see a little bit fire is coming through, and this looks much more pleasant to me, and it looks as it should be. Perfect. Now we have to go into the Mocha AE and do the rooftop. But the roof is more or less exactly the same as we did the forefront and the side front. So we did the whole tracking, and we are back with all layers we have masked out. So we have the main layer, we have the forefront. So let's see, we have the roof. So it's the roof tracked. We have also the iron part in front of the cabin. We have the forefront and we have the side panel. Everything is tracked. Perfect. We are closing it and we are back in After Effects. So let's see the whole composition without the layers. We are zooming in, and now we are also see the difference between a sharp edge of the roof and a little bit of feather on this side. There is much more realism into the scene. So from my point of view, it looks very good right now. Unfortunately, the smoke is a little bit too dark from my tasting. So we have to lighten it a little bit up, and therefore we are going into the layer of the simulation and do a little bit an adaptation with a curve adjustment. And when we see there is additional black, so we have to raise up the lower parts, and this is much more integrated in our backplate. Perfect. Okay, it looks very promising now. Perfect integrated, but what's missing? You can't see the heat. That's why we make a new adjustment layer and integrate the heat distortion plugin from Video Copilot. And only then the whole thing comes to life and looks even better and much more realistic. So we are going into the settings of the heat distortion plugin, and we are tweaking some settings. We are tweaking the noise scale, we are tweaking the speed and the heat amount, and so it looks promising from my point of view. Yes, perfect. But the heat is not visible on the whole scene. It's just on the housing itself, a little bit below and above, because heat is going upwards, and we don't see the heat on the whole frame itself. This is not a big problem. We are masking the heat itself out of the frame. We are going to the first frame, make a keyframe of the mask, go to the last frame and do a little bit adaptation of the mask. It automatically creates another keyframe, so it is into that frame, and now we have the heat distortion only on the heat itself. Perfect. A little bit of adjustment on the heat distortion amount, and now we are ready for the final composition in DaVinci Resolve. Perfect. Super. We then export the composition as an Apple ProRes 422 HQ. Leave the export audio disabled. Choose the right folder and name. And we are back in DaVinci Resolve, where we have an adjustment layer. And in the adjustment layer, we did a little bit of color grading and a vignetting. And we change now in the timeline, we change the output blanking to 2.35, and it looks much more cinematic. And finally, we have just to reposition the whole scene on the y-axis, and now we are finished. Wow! I think it has become a great VFX shot. I love it. So, thank you for watching. Again, if you like this tutorial, then please give me a thumbs up or leave a comment and subscribe to my channel. I would be very happy to stay in contact with you. And we will see you next time. Bye.